All right, now we're looking at example 13 here in section 3.1. And it's determining a quadratic function in vertex form based on just the graph of that function. So you see we have labeled here, step 1 is to substitute the vertex as point hk into the vertex form of the function y equals a times x minus h squared plus k. So we look at the vertex of the graph, which is right down here, which you should be able to count off as that's 5 in the x direction, and we're down -4 in y. So we will be able to write our vertex form here as x minus 5 and squared minus 4. Right? So now the next step says to substitute another point from the graph to determine our a value. So we want to look at the graph, and depending on what you're given, sometimes this will be easier than other times, but this graph is a good one, so we can clearly see we got a nice point there. Sometimes you're not always given nice points. There's another one right there, so either one of those would work, any one. So I'm going to use our point here of, what was that, -1 in y and 2 in x, so 2, -1. There, like that. So we'll go over here now. So our y point, we'll plug this directly into our vertex form equation. So -1 is equal to a times 2 minus 5 squared, subtract 4. So -1 is a times, 2 minus 5 is -3 squared, is going to be 9, positive 9. So we'll bring that -4 over to the left-hand side of the equation to get 3 is equal to 9a. We'll divide by 9, and that'll give us, I'll do it over here, a is equal to 1/3, which gives us a final answer of y is equal to 1/3 x minus 5 squared, all minus 4. So there's your equation of that quadratic.